All right, today we're going to be talking about counting outcomes. So we're going to talk about what's called tree diagrams and the fundamental counting principle. So tree diagrams, fundamental counting principle for our vocab. Let's go to our first example, and we can show you what a tree diagram is all about. A greeting card maker offers three birthday greetings on four possible colors, as shown below. And we're going to do a tree diagram to find out the number of cards that can be made from these choices. So the greetings can either be humorous, traditional, or romantic, and the colors are either blue, green, orange, or red. Well, how do we do a tree diagram? So we start off by branching off into these three types, humorous, traditional, and romantic, and then each of them has branches coming off. And if it's humorous, they have four different colors options: blue, green, orange, and red. So we have humorous blue, so HB, humorous green, HG, orange, and red. And then we have the same possibilities for a traditional: blue, green, orange, or red. And we can go ahead and list those out. And then the same with romantic. By doing all of this, we can now see how many total different possibilities we have. And we have 12 of them. So there's 12 possible cards. Now let's use this to find a probability. So Henry wants to roll a number cube and toss a coin. What's the probability that he will roll a 3 and also get a heads? So let's start with the number cube. What are the possibilities with the number cube? The number cube has 1, 2, 3, 4, 5, 6. So we have all these different branches that we can have for the number cube. Now each number cube will get a coin toss. So if I get a 1, I have a possibility of a heads or a tails. A 2 has a heads or a tails. 3 has a heads or a tails. And we can go through all of this. Notice by counting up all the different possibilities on the bottom here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of them. And how many of them are 3 and a heads? Well, only this branch with this 1. So it's 1 out of the total of 12. So there are 12 possible outcomes. There's only one that has the 3 in the head, so 1 out of 12, which is our answer. That leads us to the fundamental counting principle. We do not want to do a tree diagram every single time. Imagine if we had 100 different possibilities. To do a tree diagram that large, it would take up plenty of space. So there's got to be an easier way, and that's called the fundamental counting principle. What we end up doing is just multiplying the two possibilities. So we had 3 different types of cards and 4 different colors. So it was 3 times 4, or the 12 different outcomes. The last one, a number cube, which had 6, and a coin, which had 2. 6 times 2 again was that 12. Here, 5 possible decks and 3 possible sets of wheels. So there are 15 possible skateboards that they can make. All right, let's try one of these problems. A cell phone company offers 3 different payment plans, 4 different types of phones, and 6 different wraps. How many phone options are available? So we're going to do how many each possibilities. So 3 times 4 times 6, which is 72. So there are 72 different possibilities for this phone company. How about a sandwich shop? 4 choices of bread, 5 meat, 3 cheese. 4 times 5 times 3, 60 choices. Real simple. A lot easier than doing that tree diagram. What's the probability of winning a lotto? When the winning number is made up of 5 numbers from 1 to 20. So we're going to talk about each of the 5 numbers, the first, the second, the third. And how many possibilities are there? Well, there's 20 of them. So it's 20 and 20 and 20 and 20 and 20. Multiply that all together and we get 3,200,000. So we have one possibility out of 3,200,000 in order to win this lottery. What about a password? 3 different letters, 3 different components, sorry. The first one is a letter, so 26 possibilities. The last 2 are 1-digit numbers, 0 through 9, so there are 10 of them and 10 of them there. So 26 times 10 times 10 is 2,600. That's how many different possibilities we have. And that's all I have for you today.